Hi everyone, my name is James Farrier and I'm the CTO of Appsurify. Today I want to show you a quick demo of TestBrain. TestBrain plugs into your existing testing processes to make your automated testing run up to 10 times faster and helps you focus your manual testing on the risks. I'm going to start with the manual testing, since that only requires integration with the code repository. Then we'll connect to the CI/CD pipeline and show you how it can speed up your automated testing too. To get started, we just need to set up the functional code areas. The code areas should be set up in the way you think of code functionality. That usually matches the folder structure of the code, and if it does, you can just press this button to automatically create the code areas. You can then make any adjustments you want, including renaming the areas or moving specific files or folders. Now we're ready to start using TestBrain to prioritize our manual testing. Let's click here on the risk map. Then we choose the time period. I'll pick the current sprint, then TestBrain generates this risk map. When we first connected TestBrain to the repository, the machine learning analyzed the commit history to understand the risk of a defect. I don't have time to go through the details here, but if you're interested in learning about how TestBrain machine learning works to identify risks in software commits, you can read the details on our website at appsurify.com/risk-model. TestBrain then analyzes the risks in each new commit, which you can see here. The outer ring here shows all the commits during this time period colored by risk, green for low risk, red for high risk. Then the commits are mapped to the code areas in the inner ring, which is also colored for risk. This map is like a heat map to help your team know where to prioritize their testing. This project has a total of around 20 code areas, but during this sprint, only 4 areas were changed. Just from a glance, we can see the account section has the highest risk, so we'd want to focus our testing on here. Then double check the transfers section and spend a little time on the payments and online account sections. The other 16 areas haven't changed, so we don't need to spend very much time testing them. Next, I want to show you TestBrain's alerts. Within our project configuration, we click on alerts. Alerts can give you more time to test the most critical changes by notifying you whenever it sees a high-risk commit or if areas of the code that you have flagged have changed. Let's go ahead and set up an alert. Just click here to add a new alert. You can choose whether to send the alert immediately or combine them into a single daily or weekly alert. Then pick the type of alert. We can get an alert for high-risk commits. We can build our own alerts based on a variety of risk factors. We can be notified of new defects. We can get a report of test runs, or be notified of changes to flagged files or folders. Or finally, get a report on the test prioritization results. I want to be alerted to new high-risk commits, so I just select this and add my email address here as a recipient, and that's it. Now each time there's a high-risk commit, I'll be notified immediately. You can use the alerts to get the developers to double-check risky changes, or you can make it part of the code review process. Mostly, it gives you a heads up so you have a little more time to test the most critical changes instead of finding them at the end of the sprint. So let's switch gears now and talk about the feature that I first started building. How to speed up your test automation. If you're like most companies, you have a lot of automated tests and they take a long time to run. But it's testing everything instead of just the changes. And that's a waste of time and money, since most tests are completely irrelevant to what's been changed. That's where TestBrain can help. TestBrain maps your tests to the code. Then for each code change, it figures out which of the tests are automatically needed for the changes and connects them to the CI to automatically run them. Usually that's around 10 or 20% of the test suite, so your tests will run 5 to 10 times faster. Because your tests run much faster, you can test each commit immediately and get results to the developers right away. They can then fix any problems before they move on to their next task. So let me show you how this works. First, we need to add our test suites. For this demo, I'll add our Selenium tests. Then we can do an initial mapping of the code to the tests. This step is optional. The machine learning will figure out the mappings by itself over time, but if you do an initial mapping, it can reduce the time substantially from the very first build. If your tests match the code structure, mapping only takes a few minutes. From areas, we click on linked areas, and then we check the boxes to associate the code areas here with specific tests here. If there are cross dependencies, you can check multiple code areas. The machine learning will gradually get more fine-tuned to associate individual tests to specific files to continue optimizing the testing. But this rough mapping will give us a great start. Lastly, we need to add an executable script into the CI pipeline to tell the CI tests to run. TestBrain generates the script for you. First, we specify which priority tests we want to run. The tests are grouped into high, medium, and low risk based on the probability of a failure for the specific code changes. Most users will want to run just the high and medium priority tests. However, if you want a quick test run, because you're going to run the whole suite overnight, you could just run the high priority tests. And prior to the release, you'd want to run the full set of tests. Next, we specify the build failure criteria and whether to rerun failures. I'm going to set this up to only fail the build if there are new defects, meaning the build will not fail for flaky failures and won't fail for known open bugs. And I'll specify that we want to rerun the failures 3 times to see if they were flaky failures or real defects. Now we'll just copy the script and add it to our CI pipeline. You can use TestBrain with almost any CI, but most people are familiar with Jenkins, so that's what we'll use for this demo. I previously ran the full set of tests without TestBrain. We can see the tests took 41 minutes to run without TestBrain. Now, we'll add our script to Jenkins as an executable step. As each commit comes in, instead of running all the tests, Jenkins will do an API call to TestBrain to get the list of tests to run and the criteria for whether to fail or pass the build. Now we'll rerun the tests and see how long it takes with TestBrain installed. We can see TestBrain cut the test time down from 41 minutes to 3 minutes, reducing the test time by more than 90%. That's a huge improvement. Next, let's see what happens when there's a bug. Let's get another test running, but this commit will contain a failure. We see here the build failed, as expected. With 3 test failures. And we can see here that TestBrain determined the 3 failures were caused by the same problem, so it grouped them together and raised a single bug. TestBrain both organizes failures into bugs and automatically tracks the bugs for you, saving you time. Now it looks like another commit has just come in from a second developer, and the build passed this time, but let's take a closer look. We actually had 5 failures. The first 3 are the same ones that failed due to the first developer's bug. That defect hasn't been fixed yet, so we expect these tests to fail. Since we've set TestBrain to fail only on new defects, it notes these failures but doesn't break the build. It looks like the other 2 failures were caused by a phone losing connectivity. TestBrain determines they were flaky failures instead of code defects. Flaky failures are when a test fails because something went wrong with the test itself. If we look at the details, we can see here that test 1 and test 4 were automatically rerun. They both passed and failed, which is how we determined this defect was flaky. Without TestBrain, flaky failures will break the build, as you've probably experienced. So even though 5 tests failed in this run, there was actually nothing wrong with the code changes in this commit, so the build passes. It looks like the first developer has just made a new commit, and the build passed this time with no failures. If we look over here, we can see the 3 tests that used to be broken now all pass. And we see here that TestBrain automatically closed the bug. So that's the demo of TestBrain. To summarize, TestBrain makes your QA testing faster in 4 ways. First, it makes your automated testing much faster by finding and running just a small set of tests needed for the specific code changes instead of running the entire test suite. Second, it quarantines flaky failures and prevents them from breaking your builds. It also tracks the bugs to save you time. Third, the risk map shows you where to prioritize your manual testing based on the risk of a defect. And lastly, TestBrain alerts you to risky commits and changes to flagged areas of the code. If you have any questions, please reach out to us. Thanks for watching.